Hey everyone, welcome to our final video in the surds section of this course. In this entire topic we are looking at surds and indices, and this is the very last concept we want to mention when we talk about working with surds. And this is the idea of something we call rationalizing the denominator. Now I've given you a fraction here with a surd on the denominator. Now the title of this video is quite self-explanatory for what we want to be doing, but the way to get there is a little bit tricky. But we just want to make some initial observations about what we have here. We have a denominator. Our denominator is a surd. And what type of numbers are surds? They are irrational numbers. So when you're given a surd fraction with a surd on the denominator, this is going to be an irrational denominator. And the process we want to learn in this video is how we can think about making this denominator rational. So just like when we were looking at adding and subtracting fractions, when we changed the denominator, we manipulated the fraction to make an equivalent fraction with a different denominator. We're doing a very similar thing here, except what we want to do is we want to make this denominator, root 3, a rational number. Now, let's take a closer look at this. So 2 over root 3. Now, if you remember when we looked at our fractions and finding lowest common denominators, I don't know if we had 2 over 3 plus, 1 over 2. We wanted to find, well, what's a denominator that we can make both of these numbers into? And what we did was we times the 3 by the number 2, and what we did to the bottom, we did to the top. And that gave us an equivalent fraction. That gave us 4 over 6. So this was just another way of writing 2/3, but with a different denominator. We're doing the exact same thing here. So we're going to make some kind of change to this denominator root 3. And that's going to involve a type of multiplication. I want you guys to think and pause the video and really reflect on this idea. There is only one number that we can multiply root 3 by in order to get a rational number. So if we tried a few things, root 3 times 2, for example. All right, that gives us 2 root 3. That's still a surd. Root 3 times root 8. That gives us root 24, still a surd. You can have a play around with this if you want a little bit, but if you put all of these into your calculator, you're going to get some surd, some decimal point with no pattern, no recurring theme at all. But there is actually one number that we can multiply root 3 by in order to make it a rational product. And we talked about this in the previous video a little bit. The only way I can get a surd to a rational number is to multiply it by the identical surd. If we multiply root 3 by root 3, what's that going to give us? Well, from the last video, we looked at this with a couple of examples. That's going to give us 3. If we had, root 6 times root 6, and try these in your calculator, please feel free. And if you can find another number, that's going to be really good. But the easiest number, the lowest number, most simple number we can get to, rational number we can get to, is going to be when we multiply the surd by itself. Root 6 times root 6 gives me 6, so on and so forth. So using this information, let me bring it down here, I can make root 3 into a rational number by just multiplying it by root 3. And remember, we just can't do something to the denominator because this will just change the number entirely. To get an equivalent fraction, we have to do the same to the top as we do to the bottom, because this thing here is equivalent to multiplying by 1. And the only way we don't change our number to over root 3 is if we multiply it by 1. We get equivalent fractions by, in essence, doing some mathematical manipulation, but it always results in timesing by 1 because the denominator is the same as the numerator. So to get an equivalent fraction, we want to do the same to the bottom that we do to the top, or vice versa. Okay, so timesing these together, that gives me 2 times root 3 on the top, or just 2 root 3. And on the bottom, root 3 times root 3, we saw down here that that's just going to give us 3. What we have essentially done, we have gone from an irrational denominator to a rational denominator. And we have done this with a little bit of mathematical manipulation in the same way we manipulated fractions when we added or subtracted those. Okay, let's look at a couple more examples. Let's do some slightly harder ones. So I have 2 root 6 over 5 root 2. Okay, now, regardless of whatever number is in front of the surd, the only way we can get a surd to a rational number is multiplying by that surd. So we're going to multiply the denominator here by just root 2, because that's going to be enough to make this from an irrational number to a rational number. And what we do to the bottom, we are going to do to the top. So what I end up with is, let's do the denominator first. I get 5 times root 2 times root 2. Okay, and we can write root 2 times root 2 as just 2. So in essence, I'm doing 5 times 2 on the denominator, and on the numerator, I'm getting 2 root 6 times root 2. So my 2 stays here, and the root 6 times the root 2 is going to give me root 12. And now I can start to think about simplifying this. So 2 root 12, 5 times 2 on the bottom is going to be 10. So I can see top and bottom, I have a number that can go into both 2 and 10. That's going to be the number 2. So I can simplify this fraction. The 2 becomes 1, the 10 becomes 5, which gives me that just gives me root 12 over 5. And this root 12 we can simplify because one of the factors of 12 is 4, which is a perfect square. So my root 12 is going to become root 3 times root 4 on 5. And my root 4 is just going to be 2. So that gives me 2 times root 3, or just 2 root 3 over 5 on the denominator. Okay, let's do one more. And we'll make this a little bit trickier. So I have 1 minus root 3 on top of root 3. Okay, once again, to rationalize the denominator, I want to multiply it by itself. I want to multiply the surd by itself, because that's the only way we're going to get to a rational number on the denominator. And I'm going to do the same thing up top. Now here's where we have to be careful, because we have two terms on the top. This is a binomial expression. It's made up of two numbers. So when we multiply this thing by root 3, we're multiplying root 3 by both of those. So we're going to put a bracket here to show that we are timesing root 3 by both terms, because we can't simplify this thing at all. We treat it like two terms in the same way we'd have, for example, x plus 2 when we did expanding brackets a while back. Now, root 3 times root 3 on the denominator gives me 3. And now I just want to expand the numerator via the distributive law. So, my root 3 is going to multiply by both of my expressions in the bracket. So root 3 times 1 just gives me root 3. And root 3 times minus root 3 gives me minus 3. Because we have a negative here. And root 3 times root 3 gives me just 3. Because I'm timesing the same surd. And I end up with 3 down the bottom. So we have rationalized the denominator in all of these cases. We've gotten it from an irrational number and done some mathematical manipulation to make an equivalent fraction, so the same fraction just written in a different way using a rational number instead. But that brings us to the end of the video. Thank you so much for watching, and I will see you in the next one.